So those of you who are here, be ready, okay? So you have 5 minutes to do this, okay? And what I would like you to do is, I would like you to fill in the answers that you have gotten. Hopefully you got the answers, okay, into this Google form, okay? I'm sending it into you now lah. So all you have to do is just question 1, what is the answer? Question 2, what is the answer? Question 3, what is the answer? Okay, and in 5 minutes, okay, we are going to move on to the next activity. Okay, I'm assuming that kamu sudah tengok atau sudah cuba menjawab the objective questions in the tutorial 6.1. So buka kamu punya module tutorial 6.1, okay. There is question 1 to question 13. So in this Google form, you will see question 1 to question 13 lah over there. Okay, so fill in the answer that you put, okay, and then after that, we will continue with the next thing. Okay, let's go through this entire thing. We're starting with group number 1 now. Who's presenting for group number 1, please? Go ahead, Damien.
So, first question is state one characteristic of beta particles. The characteristic of beta particles is negatively charged. Boleh juga letak medium ionization power. So second question B, based on diagram 3, determine the half-life of potassium-42. Show on the graph how you determine the half-life of potassium-42. So buat draw a dotted line situ. So we get 11.5.
Hold on, kejap. Am I the only one that apa ini? Saya rasa dia sampai sini.
Secara logis tu sir, wrongly plotted.
Yeah. Why did you stop halfway? Siapa yang hantar ini ya?
Dueling. I didn't see it. I was doing late at night.
Okay, Elijah. Okay, I think that if you had done this is how much is this everybody? 12 lah kan? 11.5 or 12? Sounds 12 lah kan?
11.5.
11.5 ah?
Yeah.
Hold on now. What is distracting me really is the fact that Elijah, you stop halfway, you know. And then I'm like, what is this? Okay, 11.5 is correct. Except that, itulah, kau tidak sampai hujung oh my goodness. Okay, fine. Tak apa. Nanti masa SPM kau akan ambil masa terang-terang, bukan late at night. Okay, teruskan, Damian. Thank you. 11.5. Alright.
So, question C. Based on half-life, state why potassium-42 is suitable to be used as a trace. Potassium-42 is short half-time because it takes a short time to decay.
Okay.
Calculate the time taken for radioisotope potassium-42 to reduce to 1/8 of its initial activity. So 1 times 1/2, 1/2 times 1/4, 1/4 times 1/8. So ada 3 arrow, 3 times 11.5, we get 34.5 hours.
Okay, good. I think the explanation is fine. Cuma saya ada satu komen sajalah ini ya. So why potassium-42 is suitable as the trace? So of course, you know, by saying the short half-life is correct lah. Okay, it's 11.5 hours. Generally hours, minutes, these are very short half-lives. Okay, but so what lah? The question is, jadi kenapa? What is so important that the half-life is short? Kenapa the half-life mesti pendek? Okay, and I would actually come back to what is this being used for? Dia cakap the radioisotope, okay, is used as a tracer to measure the quantity of salt in the human body. Okay, so dia digunakan sebagai pengesan untuk to see how much garam is inside your body lah. Okay, untuk mengetahui sama ada kamu ada masalah kesihatan, high blood pressure, etc. etc. So when you have something with a short half-life, okay, dia mengambil masa yang cepat untuk decay. Okay, but ultimately it is safer for the patient. Okay, ultimately ini, I mean, kalau kau tulis short half-life saja kan, saya khawatir yang kamu tidak sebenarnya menjawab soalan. So what if it is short half-life? So short half-life, especially berkaitan dengan badan manusia, it is safer for the human being lah. Okay, so I would actually answer it is having a short half-life is safer for the patient. Okay, because if you have something radioactive inside your body, yang dia punya half-life is thousands of years. Okay, it's going to be very suffering for you lah. Because sikit-sikit dia decay, sikit-sikit dia decay. Every time it decays, you fall sick. Okay, so we want it to faster decay. Okay, so that it will be safer for you. Will it be ultimately all gone? Of course not lah. We have learned that bila dia decay, dia tidak akan mencapai kosong, tetapi dia akan sangat berkurangan. So we won't feel the effect so much. Okay, so ini sajalah penambahbaikan yang saya mau cadangkan for this group. Alright, good, thanks. Question number 2, please. Sorry, is this? No, this is not question number 2. Who is question number 2? Oh, I know, it's Irdina's group. This one. Kan?
Yeah.
Okay, go ahead.
What is the meaning of half-life? Half-life is the time taken for a sample of radioactive nuclei to decay to half of its initial number.
Carry on.
Give one reason why iodine-131 undergoes a decay process is to become a stable nuclide. The mass of iodine-131 after 32 days is 12.5 gram. We counted by 32 days divided with 8, which is 4. So they undergo 4 half-life. So from 200 gram, which is the initial mass, we kasih half four times.
Okay, all right. Okay, before you go on to the last one, this is dia bukan salah, okay, it's not wrong. I just may want to just offer an alternative lah. If you say meaning of half-life is yada, half of its initial activity, okay, pun saya boleh terima. Okay, initial number is also correct lah. Okay, but generally I think even the book tells us the word activity lah. Okay, B is probably something that I would have a little bit of an issue with. I would probably say is to become a stable nucleus daripada nuclide. Okay, because nuclide ada ni, there is a difference between the word nucleus and nuclide. Okay, but I cannot really remember. But I would have gone with the word nucleus lah instead of nuclide. Okay, alright. Thank you. Next, belum habis lagi kan? Satu lagi soalan. Okay. Sketch a graph to show the process. Okay, let me ask you this question now. This group lah, the second group lah. So this one is 2 marks. Where do you think the 2 marks goes? Any opinion?
And
the shape of the curve.
And the dotted line for.
Okay, I would also say the same thing. The shape of yeah, the dotted line I guess is also important. But I would say that if it is a 2-mark question, of course the shape of the curve is important. You want to make sure that the curve never touches 0. It's a very important thing. Okay, when you draw a decay curve, make sure that it doesn't touch the bottom. Okay, so ini yang kita tidak mau. Okay, so that's 1 mark. Second mark is you show me 1 half-life. So you start with the 200 yang sudah diberi, you go with the 100 and you make sure that over here it is the 8. Okay, to show 1 half-life. If you want to go forward and you want to show 2 or 3 half-life, also no problem lah, can also. Okay, tapi yang saya mau nampak adalah this titik over here, 8 dan 100. That one, itu saya mesti nampak. Okay, and I like the fact that at least in this example, Jacinta, she used dotted line to show very clearly lah. Okay, that one half-life is like this, two half-life is like that. Okay, so it's very easy for people to give marks. Okay, this way. All right, good. Question number 3 is, question number 3 is the scanning group. Okay, this is Melanie's answer. So somebody besides Melanie, please.
One of the characteristics of gamma radiation is that it has no charge.
Okay.
And the B1, we don't know the answer.
Okay. All right.
Okay, so B2, the question says, the activity of the technetium-99m decreases to 1/8 of its initial activity in 18 hours. So we find exactly how many half-lives is equal to 18 hours, which, as you can see here, is 3 half-lives. So in order to find the half-life, we divide 18 by 3, which equals to 6 hours.
Okay. All right. Carry on.
And for question D, it is a beta decay, so the nucleon number does not change. So A is 24, while Z is 12 because there's an electron.
Okay. First of all, let's talk about gamma radiation now. One of the characteristics, obviously, gamma radiation is no charge, and it's the most famous characteristic. Remember, when you talk about characteristic of any radiation, like Damir's group just now, you can talk about penetration power, or you can talk about ionization power, ionizing. Okay, ionizing power. You can also say that gamma radiation is actually an electromagnetic wave. Okay, it's just an added stuff lah. Okay, if you want to give more than one characteristic. Tapi ini semua adalah characteristics of gamma radiation. Okay, now this is a very important thing which I probably did not cover in my class, but I should mention this lah. So the detector has already shown a reading before the patient is put into a scanner. And I think question number 4, you are also facing this problem. State why there is a reading walaupun tiada bahan radioaktif di dalam scanner tersebut. Okay, why is there a reading? Okay, why is there a reading? Why can we have a reading? Tapi sebenarnya tiada bahan radioaktif. Okay, now there are 2 causes for this lah. The number 1 cause is background radiation. Okay, background radiation. Now, background radiation can come from anything around us that may have a little bit of radioactive material inside. Okay, for example, if you bring a detector into the outside, into the outside lah, okay, and then this one, you will always definitely feel a little bit of reading, especially when you put it nearer to a rock. Okay, rocks are much older than us lah. Okay, rocks are, like millions and millions of years old, and we don't know, mungkin sebarang batu yang kita pegang itu kan sebenarnya di dalam there is a radioactive element inside. And although it's very very small lah, sangat-sangat kecil, and over the years it has already, dia decay sampai tinggal sikit saja, tetapi hakikatnya there is still a little bit more left, and so we call this background radiation. Okay, radiation, radioactivity that is caused by things that are around us. Okay, everything actually, okay, everything actually dia sedang menyinarkan sesuatu lah. Okay, cuma we can't really see it lah. A second cause is what we call cosmic rays. Okay, cosmic radiation or cosmic rays lah. Okay, because one of the biggest sources of radiation, like it or not, okay, is actually our good friend the sun. Okay, so when the sun rays come upon us, of course, kita berada pada jarak yang sangat jauh daripada matahari. For us to feel like, oh no, I'm mutating, nobody does that lah, okay? But we are at such a distance from the sun where when the radiation hits us, it doesn't really affect us so much lah. Paling pun it just causes sunburn and possibly skin cancer lah. Okay, but that is because of the radiation from the sun. So when you put a meter, and this one actually question number 4, it is more for question number 4 lah. When you put a meter into the air, especially if you're in the hot sun, okay, you will definitely get a slightly higher reading than normal. Okay, it is still a small reading, but it is slightly higher lah, because the detector is detecting some radiation from the sun. And the radiation from the sun, kita panggil dia sebagai cosmic rays. Okay? It sounds like a lot of like, wow, hebatnya this term, cosmic rays. Okay, and you think of the Avengers and the Eternals and blah 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 lah. Okay, but basically that's it lah. Cosmic rays actually cause radiation. It's just that we're very far from the sun in order to feel that radiation. Okay, but that doesn't mean this is not an excuse for you to go into the sun as you like with no sunblock and anything. Come on, guys. Okay. All right. Is this done? Question 3 done, right? No more, right? Yeah. Okay. Let's go to question 4, please. This is Jennifer's group.
What is beta particle? Beta particle is high energy electron emitted by an unstable nucleus, or we can say fast moving electron. B, what causes the reading show in the counter in diagram 4.2? Background radiation and cosmic ray.
Okay.
C, a sheet of aluminium is
Hold on. I haven't even changed this one. You already okay? Thank you.
A sheet of aluminium is placed between the radioactive material and the Geiger-Müller tube in diagram 4.3. What will happen to the reading of the counter? It will decrease.
Okay.
It is give one reason for the answer in 4C1. Beta ray cannot penetrate aluminium.
Okay. I think you
D.
should put in the word. Sorry, I think you should put in the word aluminium inside lah. Okay, next.
The decay of uranium found in the rock can be represented by the equation below. Determine the value of x and y. X is 8 and y is 6.
Yeah. Okay, I think this calculation is quite easy lah, kan? 4x, 2x minus y. Okay, good. All right. Question number 5, please.
The meaning of radioisotope is an unstable form of chemical element, or you can say isotope. And B1, the difference in the nucleon number is 4, because 238 minus 234. Okay. And B2 also the same. The difference is 4. And for C, the difference of proton number between uranium and thorium is 2.
Okay.
And for B is also 2.
Okay.
So the conclusion, when alpha decay occurs, the nucleon number decreases by 4 and the proton number decreases by 2.
Okay.
Okay, so we draw the alpha particle path. So because it is positively charged, the alpha particle will go to the negative plates.
Okay. All right.
Okay, so that's all.
All right, good. I want to talk about this drawing. So, when we were comparing, masa kita membandingkan alpha particle and beta particle, I said that the alpha particle is very, very heavy. Very heavy means dia akan terpesong, tetapi dia akan mengambil masa yang lama untuk terpesong. So, I like the fact that, at least in this diagram, Wilson has drawn a long pathway, okay, to show the alpha this one. If you had drawn, kalau kamu terlukis macam ni, okay, terus pergi sini kan, I would have marked this wrong, because this would be, yes, correct lah, dia pergi ke negatif, tetapi dia tidak boleh bergerak terlalu cepat lah. And only the beta particle would have moved a lot faster. So if it is beta particle, then you are talking about like this. Dia akan cepat-cepat sampai ke plate. But usually the alpha particle dia akan terpesong, tetapi it will usually not reach the plate lah. So you want to make sure that there is this distinction between number one, dia akan pergi ke plate mana, and number two, how fast dia terpesong lah. Okay, so this is difficult lah. Okay, difficult to deflect because it is heavy, banyak inertia. Okay, the bigger the mass, the bigger the inertia. Okay. Secondly, this one, the meaning of radioisotope, I would not really put this form of chemical element. Okay. I have seen people talk about this before. This specifically for exam lah. So radioisotope generally is one of the easier definitions. Unstable isotope. You don't have to talk about isotopes. Okay, because isotope is a chemistry thing lah, so we're not really interested in what is isotope. Okay, two elements are the same number of protons but different number of neutrons, blah blah blah. All that is chemistry lah. We are just interested in what is radioisotope. Radioisotope is an unstable isotope because isotopes same element kan. Okay, you can have, for example, hydrogen 1, hydrogen 2, and hydrogen 3. Okay, so hydrogen 2 and hydrogen 3 are unstable. Okay, but this is a stable isotope. Okay, all three are hydrogen. It's just that they have different things that make up the hydrogen. This one. Okay. All right. Good job, everybody. I want to address the two questions that were asked by our friends just now. Let me see if I can open this one now. Is it question 12 and question 13? Do you still want me to explain this, Lester and Eudina? Let's go with question 12. Why is everybody this one question 12? Did you read the question properly? 25% of gallium-65 atoms have decayed. When we do the half-life thing, right, the numbers represent what? The numbers represent the amount that hasn't decayed, yang sudah tinggal. So if 25% have decayed after 15 minutes bahkan, yang belum decay sebenarnya adalah 75%. Kan? 75% haven't decayed. But you can't use 75% for half-life. You have to use 50%. So if 25% is 15 minutes, you can safely say that 50% yang sudah decay will be 30 minutes. And so the half-life is 30 minutes lah. No? A? Unless I put the wrong answer lah. Did I put the wrong answer? Oh, okay. The answer is A. Definitely A. Okay. Yeah. So this is a very common paper 1 question that we need to be very sure lah. When we draw the decay series, bila kita lukis itu bahkan kita sedang menyatakan berapa banyak yang tinggal, how much is left, not how much yang sudah decay. But this question is asking, dia bagi tahu 25% has decayed. I'm quite sure that a lot of you did what, right? 100, 50, and then 25. Kan? And then you go, oh, okay, 2 half-lives, therefore the answer is D. No. Okay, be very careful with the question lah. Okay, all right, number 13. Number 13, who is the one that asked number 13? I think it's Lester. Yeah, Lester asked number 13. Number 13, I just want you to know that these are protons and neutrons, not nucleons. So definitely the protons is 90 is correct lah. Okay, 88 plus 2. But if over here is 90, what is the top number over here? This is 230. So the number of neutrons will be 230 minus 90, which is 140. Okay, one last thing before we go. So we have finished this subtopic. Okay, this subtopic, which is called radioactive decay. And so this is something that I learned very recently, and I kind of would like to hear from you because, it helps me to this one. So for your sort of homework today, okay, it's a very fast homework. Finish it in the next 5 minutes. Okay, please fill in this Google form. Okay, that I have already posted in the chat. Okay, fill in the Google form by today. in the next 10 minutes lah. And then after that, we are done with this subtopic. So next subtopic we will look at next week. Okay, that's it. No homework, no homework, no homework, no homework. I just want you to complete the Google form.